The only time when it is reasonable to use inheritance is when you want both hierarchical reuse of code and subtype polymorphism. If you only want one or the other, then inheritance will make the code worse. Let me explain. If you only need hierarchical reuse of code, but you don't need subtype polymorphism, then you shouldn't use inheritance, you should use object composition. So if you have a superclass that defines a method and two children, two subclasses that inherit from this superclass, but without overriding any of the members that are defined in the superclass. So as you can see here, we have a method in the superclass called method 1, but in one of the subclasses we have a method called method 2, and in the other subclass we have a method called method 3. So these methods are not at all related to the method in the superclass. And what happens in method 2 and method 3 in the subclasses? Well, as you can see here from this snippet, they call base.method 1. They call method 1 from the parent. So the purpose here is that we want code reuse. We want to reuse the implementation of method 1 that we've defined in the parent. We want to reuse that in both method 2 and method 3 in our children. And so we've learned inheritance, we look at our problem and we say, okay, actually I can use inheritance for this problem. But that is not a good solution, because here we are only looking for hierarchical reuse of code. There is no subtype polymorphism. There is no overriding. And so what should we do instead? We should just use object composition. We should not do what's up here in the top. We should do what's here in the bottom. So we should have two regular classes. Notice how these two classes are unrelated in terms of the fact that they don't share a common ancestor. Up here, the two classes have the same parent. But down here, these two classes are unrelated. However, we have these two methods again, method 2 and method 3. And both of these methods call method 1 in the third class, but this time by accessing an object rather than by accessing the parent. So objects of these two types will have a reference to another object of type class 3, where you find this instance method called method 1 that we wanted to share, that we wanted to use in both of these classes. So regular object composition, it's has-a rather than is-a. Has, not is. Composition over inheritance. And I've used the dependency arrow rather than the association arrow to indicate that it doesn't really matter at this point whether we are talking about a field in these two classes or a property in these two classes or just a local variable in a method. The point is that just the fact that we want to reuse code does not justify the use of inheritance. To use inheritance, we must both need hierarchical reuse of code and subtype polymorphism. But if we don't need subtype polymorphism, we should not use inheritance. We should just use object composition. Okay, what about the other way? What if you only need subtype polymorphism, but not hierarchical reuse of code? Then you should also not use inheritance. You should just use a regular interface. A lightweight way of getting subtype polymorphism, because that is the more flexible solution, since it allows your subtypes to implement multiple interfaces rather than just inherit from a single class. So if we have this scenario where we have a superclass called parent that defines a method and two subclasses, child 1 and child 2, that both override this method. But notice here in this non-snippet, right, in this crossed over snippet, I'm trying to say that the implementation of these two overridden methods don't call method in base. They're not accessing anything that's inherited from the parent. And so if they're not accessing anything that's inherited, there is no point in using inheritance because there is no hierarchical reuse of code. So we only have the second part. We only have subtype polymorphism, but we don't have hierarchical reuse of code. So what should we do instead? Well, in that case, we should just use a regular interface, because that is the appropriate solution for the problem that we have. We should define an interface that says that in order to be an implementation of this interface, you need to define this method called method. And then we have a number of implementations. We have class 1 and class 2 here that I should probably have called subtype 1 and subtype 2. So we have these two subtypes that both supply implementations for for the method. The implementation over here is of course different from the implementation over here. All the regular rules of subtype polymorphism apply here. Do check out my other video on when you should use subtype polymorphism. But if we assume that you are using subtype polymorphism for good reason, if we assume that you want subtype polymorphism, but that you don't actually need any hierarchical reuse of code, then the point is you should not use inheritance, you should use something simpler like an interface. Because the purpose of inheritance is to give you hierarchical reuse of code and subtype polymorphism at the same time. And if you don't want both pieces, then it is not the solution for your problem. So does that mean that I think that we should always use inheritance when we're satisfying both of these criteria? You probably guessed it. No. Personally, I think we should always use interfaces for subtype polymorphism and object composition for code reuse. So we should just do this. We should have an interface that specifies that in order to be a subtype of this interface, you need to define an implementation for this method. And then we create two subtypes, subtype 1 and subtype 2. And these two classes supply implementations for this method that's defined in the interface. And of course, again, subtype polymorphism rules. These implementations are behaviorally different so that our use of subtype polymorphism is meaningful. But what about the code reuse part? What if the method in this first subtype wants to use some particular piece of code that this method in the second subtype also wants to use? Where do we put that code? Well, object composition. Just use has-a rather than is-a. Just put that in another class. And then we make both of these subtypes use this other class. So in my mind, all of this is just simpler than digging this deep hole of confusing inheritance. But you know, each to their own. And again, notice how I use the dependency arrow rather than the association arrow to emphasize that at this level of abstraction in the discussion, it doesn't really matter if the object that we're referencing is in a field or a property, or it's just a local variable in a method. However, what should be said is that these subtypes are now coupling to a concretion, right? They're coupling to an actual class. And of course, if you've seen any of my other content, you know that I would argue that you should couple to abstractions and not to concretions. So of course, there are many cases where we should further abstract this code. Check out my other videos for more on that. But if you just take this at face value, you can maybe think of it as something like this. Maybe this other class is something like a list. So these two subtypes are both using the list class. And the point here is that these two classes are using the list class rather than saying that they are specializations of the list class, rather than saying that they inherit from the list class. So let's think about a game as an example. Let's say maybe there are two different kinds of inventories. One is like a backpack and one is like a warehouse, for example. And both of these need to store the items in a list. So would we then say that the warehouse is a list and that the backpack is a list? Or would we say that the backpack and the warehouse both have lists, that they has a list rather than is a list? Because the point is, we want to reuse code from the list class. We don't want to duplicate all of the code that's written in the list class. Probably, I assume you would agree with me that it's likely that backpack and warehouse should have lists rather than be lists. But you know, we have to look at the specifics. So I tend to favor composition over inheritance, but if you use inheritance responsibly, and the way I think about responsible use of inheritance is that we only use it if we want hierarchical reuse of code and subtype polymorphism, and never when we only want one or the other. So if you use inheritance responsibly in that way, then I mean, who am I to argue that we shouldn't use inheritance? I do it too sometimes. So inheritance is only reasonable when we want hierarchical reuse of code and subtype polymorphism, but never when we only want one or the other. Subscribe.